My name is Jeannie Morris, and this is my Exercise 6 presentation. I went ahead and took screenshots and put them into a PowerPoint for you guys because I thought it would be easier to display the different regression equations. So first we were asked to use SAS Viya to create a simple linear regression of the exam mark data. It wanted us to use exam mark as the target and hours of revision as the predictor. So in SAS Viya, the predictor will be the continuous effect, and then the target or our goal will be the response. So here were the results of running that linear regression, and it wanted us to make sure that the results we received were the same as those in the table 6.9 in our textbook. So here is the table 6.9 from the textbook, and we see that the R squared is the same. The mean square is also the same, along with the MSR, which is the mean squared error. And then we see that the F value is also the same. So our linear regression is correct. In exercise 6.2, we were again asked to create a simple linear regression, and it wanted us to use sales as the predictor. No, it wanted us to use sales as the outcome or response, and then radio advertising spending as the predictor. So here we have our results, and it wants us to create the regression equation, which I have done on the following slide. So to do this, you're going to take the estimate of radios, which we have here, and then you would multiply that by the number of radios or amount spent on advertising, and then you would add the intercept. So in doing so, we see that the outcome would be $55,473.97. We were also asked if radio is a significant predictor and what is the level of significance. So to determine this, you are going to look at your p-value, and you do want a very small p-value for it to be a significant predictor, which we do have. And you're going to want your p-value to be smaller than the t-value, which it is. It then asks us what is the adjusted R-square value and how do you interpret this. So our adjusted R-square is 0.312801. And interpreting this, a lower adjusted R-square indicates that the additional input variables are not adding value to the model. And you're comparing the adjusted R-squared against R-squared. So here we see that the adjusted R-squared is smaller than R-squared. So that being said, the additional input variables are not adding value to the model. Also, we see that both the R-squared and adjusted R-squared are very small, so we can assume that this model is not very significant or is not a very good indicator of what we're trying to predict. Next, we have exercise 6.3. And we were using SAS Viya to create a multiple regression. So when creating our baseline model, again, our outcome or our outcome would be sales, and then our predictors, because in a multiple regression you'll have more than one predictor. So our predictors of this are TV, radio, and press. And after putting this in, we received these results. And then it wanted us to add an interaction effect between TV and radio. So you do this by going to New Data Item and going down to Interaction Effect, which will pull up this page. And then you use these buttons here to add which variable you want in the effect elements, and you would click OK. And then, unlike the baseline model under interaction effects, we see this, and it gives us the following results. And it asks us what the regression equation for the new model would be. So we see that here, and unlike the simple linear regression and the multiple regression, we have multiple variables that we have to take into account. It also asks us if the interaction effect is significant, so we'll go over to our p-value and we see that it is pretty close to 1. However, compared to our t-value, it is much larger, therefore the interaction effect significance, it is not significant. And then it asks us, compared with the baseline model, how much has the R-squared increased by? So I have included the statistics for both the baseline model and the new model. And we can see that the R-squared has changed very minimally. In the baseline, it is 0.647445, and it has just slightly increased to 0.647448. So it has increased very minimally. And then if we look at the adjusted R-squared, it has also, so the adjusted R-squared actually decreased. It went from 0.643146 down to 0.641692. So as we discussed earlier, a lower adjusted R-squared indicates that additional input variables are not adding value to the model, which that's what this is telling us right here. Our additional input variables aren't adding any value. So we were asked, how might you test the R-squared significance? And usually you would do this with an f-test. However, because the change is very minimal, we can conclude that the change in R-squared is not significant. I hope this presentation was beneficial. Thanks for watching.